You can see the screen, right, guys?
Yes.
Yes, sir, we can.
Yes.
Perfect. So we'll start with the linked list. In the initial 3/4 hour session, we'll talk about it. And in the end, we'll again take up the question. Like I gave you the seat last time, and then I see there was a question by the Ashutosh in the WhatsApp. We'll also talk about that. Okay. Okay. Before I get started, both the linked list and arrays are a linear data structure. Okay. And we have already seen the arrays helps a lot. There's so many things that we can do in the case of the arrays. Can you guys tell me what is one of the biggest limitation because of which people were forced to look for some additional data structure like linked list and the others? Can you tell me what was the one of the biggest limitation of the array was?
Sir, memory, because we have to just set the memory first.
Okay.
The shifting of the any new element need to be
Okay. Shifting, adding element or shifting element? What are you saying? Adding. Anything else? And I do agree. Like these are the points, and these are very important, crucial points. But one of the biggest point you guys are still missing. Can you think of what is that biggest point? I think we discussed about that when we were talking about the array in like few sessions back.
Yeah, Vishwa, I feel that in array we need contiguous memory available. So suppose I have to store 10 values and I need a continuous allocation, memory availability for that. So that is what. And on the top of this, like linked list, how linked list will be non-contiguous. So anywhere if memory is there, by using the address we can connect and we can store the data.
Perfect. Very nice. Exactly. So basically, what happens is that suppose this is a memory space, okay, and in this one is representing that it has been occupied, and zero is representing that it is free. So 0, 0, 1, 1, then 1, then 0, then 0, then 1, then 0, then 1, then 0, then 1, 0, 0, something like. Suppose this is your memory space, right? And each 0 indicates 1 GB of the free space, and 1 indicate that it has been occupied. So if you can see here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That 10 GB of memory space is still available right now, right? But suppose I have to create an array of size say 5 GB. Now this memory space already have like 10 GB of space available, but the 5 GB space is not available contiguously anywhere. The maximum that I have is like 3 GB here, 2 GB here, then 2 GB again, and then 2 GB again, right? So nowhere in this whole memory space we have like 5 GB of contiguous memory, right? And because of which, since array requires a contiguous memory block to be stored, if our memory space is fragmented, right? Array cannot be used there. So array can't be used in the space, right? So if our overall memory is fragmented, it's very tough to use array in that case. So we cannot use it. So this is one of the biggest limitation, right? For example, say if you are working on the Java tech stack, right? Or if you're working on the C++, right? Any language as such, right? You keep on creating the objects, right? In Java, still the default the garbage collector of Java takes care of clearing up the space. But in the languages like C++, it is the developer who have to create the object and then delete the object as well, right? So because of the creation and the deletion of the object that happens asynchronously, right, at a different instances of the time, the whole memory space in which your program is running normally becomes fragmented. It gets fragmented, and because of which, if the array that you have to create is large enough and you don't have enough space at one particular location, you cannot go and use the array data structure. So even though your overall total storage is high, you still have a storage of like 10 GB of data, but still you cannot store 5 GB of arrays in it. So this is one of the biggest limitations of using array, and that is when how the linked list came into the picture. Okay, so what is a linked list then? I think most of you would be already knowing. So a linked list is basically denoted like this. So this is 1, this is 2, and this is 3. Okay, so a linked list basically has two things. One is that it has the data, and his whole block is known as a node. Okay, so a linked list basically is a collection of the nodes, and a node has a data, and at the same time, the node has a pointer to the next node. So this is what the linked list data structure is. What is a linked list? A linked list is nothing but a collection of the nodes, and each of the node will have a data. Right, for example, 1, 2, and 3 is a data in the linked list, and each of the node will know a direction, like where the next node is. So the one node knows where the 2 is, 2 knows where the 3 is, right? So one doesn't need to know where the 3 is, because every node has to know only the next node location, and the next node will know the next node location, right? So the one knows where the 2 is, and the 2 knows where the 3 is. Okay. And there are a few nomenclatures that we follow in the linked list. So the first node, which is 1 here, will be known as the head. Okay. And the last node, which is right now indicating 3, which is 3, will be known as the tail node. Okay. So a linked list is what? A linked list is basically a collection of nodes. Each of the node has two things. One, it has the data, and another, it has a pointer to the next node. The beauty of this is that now, since each node knows where the next node is, then they don't need to be stored contiguously, right? So for example, if suppose this is my memory space, so the first node can stay here, the second node can stay here, the third node can stay here, the fourth node can stay here, right? And the first node knows where the second is, second node knows where the third is, and third knows where the fourth is. So whatever the fragmented memory it is, however the fragmented the memory it may be, right? If if we have enough space to store like 4 nodes of the data, the linked list can fit in, right? And as you said, this is the starting node, so this is known as the head, and this is the last node, so this is known as a tail, right? And why we are calling it head and a tail? So the name has been taken, the motivation has got from the snake itself. So the snake can modify their shape, crawl according to the area in which they move in, right? And they also have a head and they also have a tail. Similarly, the linked list is a snake like a data structure which can crawl itself in whatever space that you put in. Okay, so the first one is known as the head and the last one is known as the tail. So the tail node will always point to the null. So the next pointer to the tail node will be null. So it means that it is not pointing to any other node, right? So this is what a basic linked list data structure is. It normally helps you to answer those questions which was unanswered by the arrays, or it is used in those cases where the array cannot be used because of the fragmented memory, right? Another advantages of the array of the linked list is that the adding a new element is very simple. It's a constant time complexity operation, which was not possible in the case of the array. Also in the array, the deletion was a very expensive operation. Again, we will see in the linked list that if we do the deletion, it's a achievable operation, right? Make sense? So far so good, guys?
Yeah.
Perfect. So let's try to define what linked list is. Okay, so since this is the first class, we'll try to define the data structure. So a linked list is basically a collection of the nodes, and we call it the list node. So I'll define class list node. I'm trying to write the code in Java, and if you guys are not comfortable in Java and want to do it in any other language, just you can transform it the same thing into any other language. Feel free to do it. So you can solve the question in any language that you want. I'll prefer Java because Java is the most common language and it is being used across the industry. So Java will be our medium of instruction. But if you are comfortable in other language like JavaScript, Python, C#, or any other language as such, feel free to modify this code in your language. So let list node. So as I said, the list node has two information. One is private int data itself, and another one is private list node next. So basically a list node has two information. It has its own data and it has a pointer to the next node. So I'll just go and create a constructor for this public. Since these are the private variables, so I go and define the setters and getters. You guys are clear what setters and getters, I understand, right? Everybody? Jahid, you know what setters and getters are?
Yes, sir.
Perfect. So this is how we define our list node. And then let's try to define a class linked list. This is very simple. I will try to quickly go through it, then we'll directly come to the problem space. So a linked list basically, now again, another thing. So since in the case of the arrays, you might have seen that whenever you have to pass the array, you have to pass the complete array, right? But in the case of the linked list, since every node knows the next node location, if we just pass the head to any method, it is equivalent to passing the complete linked list, right? I'm again repeating. In the case of the arrays or any other data structure, you will see that you have to pass the complete data structure, right? But in the case of the linked list, instead of passing the complete linked list, if you just pass the head of that linked list, one single node, which is the first node of that linked list, so it is equivalent to passing the complete linked list, a collection of all the nodes, right? So normally in the linked list problem, you will see that every methods we pass only the head node of the linked list to solve any problem, whether we are traversing it, whether we are printing it, we're finding the length, anything like that, right? So basically, the linked list will have just one starting node, which is head. Okay. Now the linked list class have several basic, methods. So this method will remain common across and we move. So for example, every data structure that you create, you should know how to iterate it. You should know how to traverse it. You should know how to find the length of it. You should know how to add element to it. You should know how to delete element from it, and you should also know how to update element to it. So basically, a CRUD operation on that particular data structure, you should be able to do it. So we'll be doing the same thing in the linked list, then we'll be doing the same thing in the array, in the stack, then the queue, then binary trees, then all the different kind of trees that we'll be covering about, then in the graph, and then in the priority queue, right? So any data structure that we go and read from now, we'll try to create our first, we implement that data structure, and in those implementation, we'll provide all the CRUD operation that we can do on that particular data structure. So here also we'll have to do some CRUD operation. So first thing that we need to do is traverse it, like public traverse, and I pass plus node. Traversal means, traversal means when you are going through each of the nodes of the linked list and printing the elements of that, right? Can you tell me how can we traverse the linked list? Anybody? It's very simple, straight, quickly, I'll move on. What should we write inside this, man?
We would create a pointer to the head and keep traversing till next.
Temp is not equal to null.
Very nice. So we write temp not equals to null, and I write first step print system dot out. Okay. So this will print all the elements of the linked list, right? So for example, if my linked list is 1, 2, 3, and null, once I run this, it will print 1, then it will print 2, then it will print 3. Okay. Can you write the same thing recursively? And this will be your assignment. Can you tell me what is the time complexity of this one?
Order of n.
Order of n. Very nice. Perfect. Okay. The second method that we need to find on any new data structure is that length, public and length. And again, I pass list node. And this is again very similar to how we did the last one. So I'll just copy this one. Just I need to add one counter here. So I'll just count equals to 0. And then here instead of this, I just include the count. Right. And then I return count. So this will give me the length of the linked list. What is the time complexity of finding the length of a linked list?
Order of n.
Order of n. Perfect. Cool. Now comes the interesting one. So now I have to write a code for public list node insert. Okay. So now the another question is that the next one is that I have to insert a node in a linked list. So already suppose I have a linked list like this. So suppose I have a linked list like 1, 2, 3, and null. Suppose this is a linked list, and suppose I want to add 5 at second position. So once I add this linked list will become what? This linked list will become 1, then it will become 5, then it will become 2, and then it will become 3, right? And then the modified linked list has a head is equal to 1. So I have to basically return 1 here. So this is what we have to do inside this function. So we have been given a head of a linked list. We have been given data, and we have given the position k where I have to go and insert it, right? And this is how we have to. Can anybody help me with the code? How can we write it? Vivek, I'll start with you. Vivek, can you help me? What is the first line of code that we should write inside this for inserting the element? Or I can do one thing. Let me copy this and let me put into our session thing. Question is clear, right, Vivek? You there?
Yeah.
Perfect. Meanwhile, everybody try to think about it. How to? It's a very simple state. I think most of you have already done it because you guys know the basic data structure. I understand, but just try to give it a look because sometimes this gets tricky. So you guys also think about and be very critical when Vivek is writing the code and suggest wherever you feel that he is going wrong. And Vivek, just think that you are writing a production level code, okay? So basically, when I say production level, try to look for all the boundary cases when you're writing the code.
Yeah, sure.
Don't use 3, use k here. Uh, why have you put 3 count?
We should be inserting a second question, right?
No. So that was just an example. That was just an example. You have to solve it for k, right?
Okay,
So the
yeah.
position is k. You have to solve it for k.
Oh, yeah.
So Vivek, in which language normally you code in your company? What is the language of your choice?
Python.
Python. Okay.
Yeah.
Okay. Because I can see it. Cool. Are you done? Are you done?
Yeah.
So I'm not going by the syntax. There are few syntax errors, but it's totally fine. So I'm not looking for the syntax, but there are few vital errors here. So can anybody tell me what are the what are the problems in this solution? Anybody?
Yeah, the main difference between the arrays and the linked list is that unlike arrays, we have to iterate in the linked list to the position where we want to insert the new node.
Okay. Okay. So I think he has done that, right? In this while loop, he has done the same thing. So if he has to go till he had to insert at the kth position, he is going to the k minus 1th node with this while loop. So I think this he has done, right? Anything else that he has missed? I see few things he has missed. Yes, very nice point. So basically, we also need to check whether the k value that has been given is a valid value or not. So if the value of k is less than equal to 0, right? So the position can only be start from the first, second, and third, right? So if the k value is less than equal to 0, then also we cannot do anything. So that is one validation that we need to do at the start. And suppose the size of your linked list is say 3, and you are trying to add the element at the k equal to 10 at the 10th position. That also doesn't make sense because we only have 3 elements in the linked list, and we cannot go at the 10th position because the 10th position doesn't exist in that particular linked list, right? So we have to first of all we have to check whether the k is valid or not, and only when the k is valid we should go ahead with the logic of inserting the element at the kth position. And this is the trick. So very nice. Paritosh, anything else that you guys think you have to say in this? Paritosh, Manoj? Okay. So basically, suppose my linked list is like this. Okay, so this is 1, and this is 2, then this is 3, and this is null. Okay. Now I have to insert, right? Now insertion can happen at this place when it is the first position. Insertion can happen at the end after end, right? After end, or it can happen somewhere in between here, right? So suppose if insertion has happened at the head, in that case, what we need to do? I need to suppose, and the 7 has to be inserted, right? So what I do, I first create a 7 new node, okay, and I simply pass the next 7 as 1. New head becomes equals to 7, right? And I return this, right? Case when I have to add 7 at the end. In that case, what I do, I simply go till the last moment, and here I come instead of null, I just add 7 here. Now 4 start pointing to 7 and 7 start pointing to null, and I have to remove this pointer. If suppose 7 has to insert it at third position, right? What I need to do, I have to first create a 7 here, right? I should know what is the next pointer of 2. So the next pointer of 2 is 3. So basically I have to make the 7 also pointing to the 3. First of all, I'll do this, right? Once I know that 7 has started pointing to 3, I have to delete this pointer, right? And then I'll just make 2 point to the 7 now. This is what I have to do, right? So basically any node can be added either at the head, either at the end, or either in the middle. When it is at the head, it's very simple. You just point that particular newly created node, next node as a head, and you return that. If it has to be done at the end, it is also very simple. Only when it is in the middle of something, what you need to do, we have to first create a new node. New node next should be the the position at which it has to be added, and the previous node you have to just pass it to the 7. This is what we need to do in the insertion code, right? And we have to consider all the boundary cases. So let me write a code for that one, and then maybe the others you can just follow it. So first of all, we check if k is less than equal to 0 or greater than length. Length method we have already found. So length of head plus 1. If that is the case, I don't do anything. You simply return the original head. Make sense? This boundary case is clear, guys?
Yes.
Why I have done +1? I've done +1 because suppose in this the length is 1, 2, 3, 4, right? So only if the k value is 5, I can go and add it here. I can add it here, right? But if k value is 6, I don't have any 6th position, right? So I only have to say that the k value should be greater than equal to 1, and it should be less than equal to the length of the array list +1. Apart from that, if anything else is there, I'll just return head. Now let's first create the new node that I have to add. So list node, new node equal to new list node, and make it as like that. And then I check if k is equal to 1. If k is equal to 1, it has to be added at start. If k is equal to 1, what I just do is that new node dot set next becomes equals to head. So what I have done is that with this, suppose k was this, so I would have just add, for example, if k is equal to 1 and data is equals to 4, in the start I have to, so basically I would have converted this linked list.
So Vishwa,
Yeah.
Do we have to check if the new node is actually a null?
No, so basically I am passing data. Data is a value, right? It's an integer. It cannot be null. It can be integer. It can be 0. It can be -1, something like that. This data cannot be null, right? It is an integer value.
Wrapper type of integer can be null.
Achha, you are saying that if it is like this, you are saying?
Yeah.
Yeah, if it is passed like this, then we need to check it that if it is a null or not.
I'm asking, can a linked list hold a null or not?
So it all depends on how you have defined this list node. Okay. So right now in my list node, I have used int as a type. You could have used integer also. And in the case if it is integer, then it can definitely hold the null value inside it, right? So it all depends on how you have internally defined your data structure. The way I defined is internally. So right now my linked list will only contain the integers, right? It cannot hold any string data. But suppose if I have to create a linked list which has to store the string data, right? In that case, I have to modify this of the type string. Like this, we'll have to do it, right? In Java, normally, if we have to actually write like this for a different kind of data types, we use Java generics, in which you write the same class, but it applies for all the different types. right? It may apply for the integer, it may apply for the string, or for any kind of custom objects. So therefore you use the Java generics. But I don't want to go in detail into the language specific things. So that is why I'm just talking about, because mostly in the data structure thing, we'll mostly be handling with the numbers. So I've just defined it for the int as of now. If we need to do for the string, you just have to go and change the data type here as a string, and it will start working for you. Make sense?
Yeah.
Right. So if k is equal to 1, it means that it has to be added at the start. So in that case, I do this. Okay. And once I do this, what is the 1, 2, 3, 4 has now been converted into the 4. 1, 2, 3, null. Right. It has been converted now. And the new head is 4 now. So what I do is that I return new.
Head is not automatically get pointed to the first node. We have to explicitly point it, right?
No. So what I've done is that initially it was 1, 2, 3. I created this 4 node, and 4 next has I pointed to the head, right? So whatever that is at the first position now is my new head. So I'm just returning this 4, which is my new head as of now.
If I would fetch the head, so I would get 4 or 1.
Okay, I got your point. So you are saying that head will still point to this, whereas the actual head is this. Okay. So basically when you return this is returning head, but if you want to explicitly do that, head now points to the new node, and you return head like. Now this makes sense to you?
Yeah.
So now the head points to the new node and the returns head. Okay. So this is what we do. Okay. I do a return statement here. I just do this, head equals to this. Else, if this is not the case, now I have to do the same logic which Vivek applied, and I have to find a count. So I do int count equals to 0, and list node temp equals to head. So basically what I need to do, suppose if I have to insert at the 3rd position, so I'll go till the 2nd position, right? And then do all this manipulation. So we'll try to do it here. So while count is less than k. So if count is less than, actually k minus 1, not k. Or I can put count is equal to 1 and this count is less than k. And what I do is temp equals to and I do count plus plus. Okay. Once I come out of this while loop, right, temp will be the k minus 1th node, right? When I come out of this, while loop, the temp will now at the k minus 1th node. Okay. So what I know do is that I find the next node to it. So list node next equals to temp dot get next, and the new node that I have created. So as you can see, so I'm here right now, and I have found next node. So this is my next node that I created, and this is 7 is the new node that I created. So basically what I do, 7 dot next should be this one. So this I'll do in the code. So my next node is new node is this one which I already created. So new node dot set next should be this next. Okay. So once I do this, basically I have implemented this part I have done now. Okay. Now I'm left with I have to remove this and I have to do this one, right? So what I do now is that I do temp dot set next, temp dot set next, I do new node. So once I write this command, it means that now I have deleted this and I have added this. This thing is done. So now things happen, right? And so after this statement is done, my linked list new element is added, and in the final I have returned the head again, right? So this is the code that we write to insert a node at the kth position in a linked list. Make sense? Is it clear, everybody?
Yeah, so I have one question. What if we have written line number 88 earlier to 87?
If we do temp.setNext earlier to 87th, so here let's try to see that. Okay, so suppose suppose that was okay, it was 3 and it was 4, and this was my new node. Suppose okay, this is my new node. Okay, so suppose you are saying that instead of doing this, I do this first. I do this first instead. So initially it was this. So if I do that line first, I have done this, and I have removed this, right? So if I did that step, this part now is completely lost. There's no way that I can get this point, right? And if I have to, then I have, right? I have lost this point, lost this connection. So in that case, I'll not be able to, connect these 2 points, which is important. I'll not be able to do this if we do that step. If you see the code, if I do line number 88, you are trying to say the new node. If I put it here before like this. So when I do the temp.setNext is equal to new node, it has done this. Okay, so basically it has removed this one, and this is the part which get executed, right? And then you do next node is equal to temp.getNext. Now temp is this. Okay, temp is this, and this next should be temp.next. So basically it will go and connect to itself.
Right.
This dot next temp dot, so it will get connect to itself. And new node dot set next is equal to next. So basically this will result in like this. So this part, so there will be a this part will get separated. So our linked list will become like this, and it's actually not insertion. We have divided the linked list into the 2 parts. So this is what will happen. Makes sense? So basically I don't need to do this. I'll write this line after this line. Make sense? Is it clear?
Yeah.
Cool. So this is how we do insertion. So this is the CRUD operation C part, right? Similarly, I have to do, right, public list node update, and this I have to pass list node head and data and k, right? So I want you guys to implement this method, taking into consideration all the boundary conditions. So what is the question? The question is that you have given a head, you have been given a data, and you have to update this data at the kth node. So initially, suppose it was 4, you have to replace it by 5, for example, right? So do it as an assignment. Okay. Another thing that you need to do is that public list node delete, and again list node head and k. So you have to go and delete the kth node. Again, you need to do it as an assignment. So you have to update, you have to delete, and you have to create. I have already shown you how do we do it, right? So everyone clear on this assignment? You are clear on what you have to do? Everybody?
No, fine.
So these were the basic things that we do with the linked list. Now let's get started with something more interesting. Okay, and that is how when a little complexity comes into the play. This is the first complex thing that we're gonna do in the linked list. I say it complex because it's little intimidating for the start. Reversal of a linked list. What I mean to say is that I have a linked list like this: 1, 2, 3, and 4, and this is null. Okay. When I say I have to reverse it, it means that the 4 should come at first, then third, then 2, then 1, and then null. So initial head was 1. After the reversal, the head has become equals to 4. Basically, you have to do this. Now, why it is little complicated in the linked list and not in the array, because in the array we can move in both the direction. We can move from the left to right, and we can move from the right to left also, right? But in the case of a linked list, once you have moved to the position once you have moved to this position, right, this second, you cannot come back to the first position. There's no way that you're coming back, right? If you move to the 3, there's no way that you can come back to the 1, right? So that is why it becomes little tricky. So I want you guys to think on this.
You can set the head out at the last position and increment each value to the next node, and then we can reverse that part.
Okay, so what you're saying is that
suppose 1, 2, 3, 4 is the list right here.
Okay.
The head is pointing to 1. Now,
okay,
what I do is I'll traverse the linked list at the last position, and I'll make the head to the last node.
Okay, so you traversed this and then you made it here. Okay, so it became 2, 3, 4, and then 1. Okay, then
I wanted the 4th element to be head, and then the first element to be the second, like that.
got your point. So what you're saying is, first it was 1, 2, 3, and 4, and you went. You first iterated from here to here, and
Yeah.
then you made 4, 1, 2,
Yes.
3, and null like this. Okay. Then what next? This is not reverse, right? This is not reverse.
Uh,
So
okay. Sorry.
somebody else was talking. What are you suggesting?
Yeah, I was saying go on removing the element from the front of the list, like,
Mm-hmm.
and add that element to the tail.
Okay. So what he is saying is that which I initially draw. So first time, what you do, you remove the first element and you put it at the last. So 2, 3, 4, 1. Second time, again you put the 3, 4, 1, and then 2. Then third time you put 4, 1, 2, and then 3. Like this you are saying.
Yeah.
But has it reversed it? No, right?
But Vishwa, suppose can't we trace the, suppose in this case 4, 1, 2, 3, right?
Hmm.
So 4 would be the first element which has been into the first, and then what I want to do is that again I can take the next element, next address of the fourth, and I can also keep the track of third, and then I'll assign the last element to the next of the first element. With
Yeah, but you are able to say this when it is only like 4 element. What if it is like very big list? You cannot keep on storing like this,
Yeah.
right? If suppose it like 6, 7, how will you store all this, manipulate this by storing into a variables? Paritosh?
okay, fine, fine.
Sir, I will take the first element from the first list, then I will make another list and put the element from this list to that list, and I'm
Okay.
continuously adding the list at the head of the next list.
Okay, so 1 I added, then I again put 2 here. So 2 I added, then
I will
another
pick 3
trigger,
and add.
and then 4. So this will reverse it, right? Cool, it works. But again, basically for this you have to create a new linked list, right? So basically you have not reversed this linked list, you have created a new linked list which is the reverse of this one. So this is not the what the question is. The question is reverse this linked list. You are not reversing this linked list, you are creating a new linked list which is the reverse of this given linked list, right? You got the difference? Let's suppose I have a linked list like this: 1, 2, 3, and 4, and it is null. Okay, you make, initially suppose my previous is equal to null, and I'm iterating. So first time what I did was, and my current is 1. Suppose this is my initial condition. Okay. The first time when I iterated, what I did was that 1 I set as null. Okay. And current I set as 2 now. So with this situation is like this: 1 is pointing to the null now, and I have a separate list which is 2, 3, 4, and it is done. This is the first iteration. Okay. And now current is this one. Okay. This is the first iteration. The second iteration, when I go now again, the current will should start pointing to the previous, right? So 2 should start pointing to the previous. Okay, and current should become equals to 3. So this should become like this. Now 2 is pointing to 1, and 1 is pointing to null, and I have another list like this: 3 is pointing to 4, is pointing to null. Similarly, I go to the third time, and now 3 is pointing to 2, and I have 4 pointing to null. And then fourth time again I have, if I go like this, right, like this, it has finally happened. So this is my final temp now, and this is my final head. So final head is, this is my final head. So if you go like this, if you write a code like this in which every time one node is pointing to its previous node, and we go like this in the loop, I think we should be able to reverse the linkage. Make sense? Is it clear? But the point is, how do we write code like this? And this is an art. So I'll quickly write the code for this. Public list node reverse linked list. Okay, if head equals to null or head dot next. Why did I did this? Head dot equal to null and head dot get next equal to null. if it has 0 or the one element, there is no point reversing it, right? So
Yeah.
we just return it,
Only
right?
one.
Perfect. And then I did list node current equals to head. And current is not equals to list node next. And current set next. Make sense? The same thing that we have written, I have written in the code here. Is it clear? Any doubts here?
No.
Perfect. So what you need to do is that this is an iterative way of reversing a linked list. You need assignment you have to do, write the same code recursively. Okay. Can you tell me what is the time complexity of this one? What is the time complexity of this one?
Order of n.
Very nice. It's the order of,
Okay.
and without any space complexity. A space complexity is order of. Okay. So this is a how do you reverse a linked list? Perfect. So far so good, guys. Cool. So we have with this, we have known what are the CRUD operation that we can do. We can know what is the size of a linked list. We know how to traverse the linked list, and what is a single linked list, right? So there are multiple topics in a linked list. So first one is the single linked list. We'll also cover a little bit about doubly linked list, and then we'll also talk about circular linked list and memory efficient linked list. But out of all the topics in the linked list, single linked list is the most important topic, both in the terms of the application as well as in the interviews. Okay. And linked list is a topic which I feel is that if you do all the question that I have given you in the seat, okay, and if you understand all these things theoretically and conceptually without mugging it, right, I can give you 100% guarantee that if somebody asks you any question from the linked list, you'll be able to 100% solve it. And this is that kind of topic. Okay. Even if I ask you to solve like 5,000 questions in the arrays, I cannot give you that guarantee, and nobody can give you the guarantee because array is such a tricky topic that somebody can ask you any trick question in that. But linked list is not a tricky; it's a conceptual topic. If your concepts are right, if you know how to play with the linked list, whatever the question somebody can ask you, you can always solve it in the real time in the presence of anybody else. So this is why linked list becomes very important topic. You should definitely try to work hard on it or with a crystal clear concept so that you are not missing any of the question. Once you have solved like 10, 20, 30 questions on the linked list, I can guarantee you that you can solve any question in the linked list, any interview, right? And again, linked list is one of the favorite topic in most of the interviews. Any good company, if you go and apply for, they will definitely have few questions around the linked list. For example, Amazon, one of the hottest topic in the Amazon interviews around the linked list and the tree. And again, tree is also like a linked list. If you have solved enough questions in the tree, there is no way that somebody can trick you in the tree questions, right? So tree and the linked list is one of the hottest topic of the Amazon. Similarly, in the other companies also like Microsoft, LinkedIn and all, right? In the starting few rounds, definitely you will find a question on the linked list. And all the mid-tier companies like Walmart and all those stuff, again, linked list is something they will definitely ask you from. So this becomes very important topic. And if you have a good hold on the linked list, definitely, out of like 2-3 rounds, there will be 2-3 questions will be from the linked list, and it give you a better opportunity in converting the interview. So please mark my words, take linked list very seriously and try to master it so that any question that comes to the interview, you guys are able to solve this up. Okay.
Can I just ask you one question?
Paritosh, go ahead.
If I'm using C# as my language, and in Java, I don't know, but in C# we have generics. I guess in Java is also used the word generics, and like we have and all those things. So my question to you is, where in the application, like suppose if you're working in Amazon or LinkedIn, how these concepts are used in main application? Like what is the need of linked list? How will you use it? We can do the same thing with list, right?
Even I have also the same question. So
Okay.
I was learning, and when I was working, I was every time I think like where this linked list will come. Array we can understand. Okay, array we have multiple options to work on, but linked list I can't find. So
and Vishwa, one more thing. Another question is, I was just reading an interview about a girl who has cracked Microsoft, and she said that in the interview they asked me entire data structure. What is entire data structure? So I went on the net and I saw that it is something when you search Bing or Google search or something, they use a structure which basically gets all the data in efficient manner. When you use these concepts like entire data structure and all these things, uh,
Mhm.
search engine and all that, they must be using database, right? For example, if there is a database, and suppose if I want to autocomplete text box, and the autocomplete text box, suppose if I want to find customers, and the customers is 50 lakhs customers, okay, or 50 lakhs products in Amazon, and I am finding mobile phone, I'll do a autocomplete with jQuery or Angular, and in the backend I'll write the simple query, get me the products whose type is smartphone, and that it will get me the list of the product. Now here where these things comes into picture, I want to understand that.
Okay. I'll take one after the another each of the question. Like the first question was that where in the like in any other language, for example, as you said in the C sharp, you have something called list. Similarly, in the Java, it is a collection something called array list. Okay, and similarly in all the other languages we have. So if you go and see the internal implementation of this list in your C sharp, or if you go and see the internal implementation of array list in the Java, you will figure it out. Internally, they are linked lists itself. Right. So if you go and see the source code of your list in C sharp, you realize that it's nothing but a linked list. Okay. So this is your first answer to that question. The second question is that not only you, but I have heard from the many of my students, like, why do we need to learn all this data structure? Why do we need to learn sorting? Because in every language that we work on, they have an inbuilt sorting function. We can directly use it. Why do we need to learn how to implement tree or how to implement linked list when every language has a standard library which provides the data structure which can directly use it? Or the other way, if I have to ask, why do we need to learn data structures and algorithm? Or is it only for the interviews that people ask how to traverse the tree and the graph? Do we have any real life implementation in the real project as well? Right? So answer to all these questions is this. So yes, every language have implemented all the standard data structure. So any language you took will have a support for list, it will have a support for arrays, it will have support for map, it will have the support for the tree. Now the question is, why do we need to learn this? Why do we need to implement this? See, so for example, what happens is that if you're working in the mid-tier companies, right? For example, the Oracle. So basically, these kind of companies are trying to solve those problems which is already present for a period of time. People already know how to solve it, right? And as a result of which, we already have few ready-made solution for these kind of problems. So that is why every language have a built-in function or a built-in data structure to support these kind of problems, and we can easily solve it out. But think about, if suppose you get to work in some company which is trying to solve which is unknown, which nobody has solved as of now. I'll take example of my company right now, LinkedIn. So what happens in LinkedIn is that LinkedIn is at such a scale right now, okay, in such a scale in the professional network that no but other company has reached till the date, right? So the problem which the LinkedIn has to solve has not been solved previously by any other company or any other organization, right? So we have to deal with few unknowns. Now, if these problems are unknown, right, even the languages, native support. For example, every language have some native support for some data structures and algorithm. Now, they were not knowing that these kind of problem can happen, so they don't have a support for these kind of scenarios. Again, take example of Google also, right? So Google has to play with so much of data. The scale at which the Google operates, no other company has ever thought of, right? So the problem which Google is solving is not something which has already been solved. Every day they are solving a new problem. They are moving to an unknown territory, right? So how do we do it? So in the case, only if they know from the basic, from the scratch, that how all the data structures have been implemented and how we can play with it, they have some previously developed knowledge on the top of which they can build some new data structures and then they can solve it. But if they just keep on depending on the feature that has been provided by default from the languages, they will not able to do it, because then their hands are bounded, because they only know that okay, for sorting there's only one thing, which is array.sort, which is provided by the Java. But only if they know that okay, there are other ways of sorting as well, like for example we have a bubble sort, insertion sort, selection sort, there are so many other count sort, there are so many new sorting algorithm which is getting researched every day. Only if they know that okay, there are few other research things that I can apply here to build some new sorting algorithm which can operate on this scale of the data, then it makes sense, right? So on a high level, just I want to say is that if you have to solve any trivial problem which the whole world already knows, right, for that the out of box algorithms or out of box data structure which a language provides is sufficient to solve those problems. No problem in that. The real utilization of this concept that you are learning will only come into the play when you have to think something new, when you have to think something build, when you have to solve some really unknown problems which nobody has seen. In that case, this concept which you have built you have understood while understanding this data structure and algorithm will come into the play. Will actually you will utilize building a new thing. Only when you know your basics right, that how these are built, you can think of building anything new, because out of a sudden you cannot start building anything new, right? So for that you need to set your basics right, and that is why we need to study this data structures algorithm. And that is why in any of these big top tier companies, who are actually solving these unknown problems, they are putting so much of stress on the basics, on the data structure algorithm. So if you take any Google interview, right, the question that they ask is always simple. They will never ask you any trick question, right? But at the same time, in each of the question, they will try to drill you deep so that they get to know that whether you understand things better or not. What is the time complexity? Why it is so that is the time complexity? So that is why understanding these data structures and algorithm becomes important if you are actually planning to move into those kind of companies where actual implementation come into the play. Does that answer your question? Does that make
Yes,
sense, Paritosh?
yes, Vishwa. Thanks.
Perfect. And the another question was that I think something around the database you're saying, right? I just missed. Can you please?
There was a scenario where the girl explained that we can use entire data structure for finding out millions of searches.
Got your point. Got your point. So normally I'll take example of Flipkart and help you to clarify your doubt. So for example, on the Flipkart, when you click on any item, right, and it gives you, as soon as you type the alphabets, you get the list of the available, items in that one, top 5, right? So normally you store the items in the database. That is very right? But between the database and the front end application, there are so many things that you do in order to optimize the operation, because the load time should be as minimal as possible, because if the load time is in like seconds, nobody will buy any item from your website. So what they do is that they manage the multiple layer of caches, right? So what they do is that normally for this kind of, the try is a data structure which we'll anyway going to cover in the coming session. Try, data structure, and ternary search tree. So these are the two data structure normally we use for these kind of cases, right? So normally what we do is that we don't load the data in the real time from the database, right? So we try to maintain a cache which provides a very high IO throughput, right? So within a milli of second, you can load 100 of records from that. And in that cache, in the memory, we try to maintain a kind of ternary search tree or the try data structure, which basically, if when you as soon as you pass any alphabet, it tries to match what are the matching words to it, and then it with that matching word, it tries to fetch the data from the cache. So actually, in the real time, you're not fetching anything from the database because that will be unoptimal. So you keep on loading the cache in the background, even somebody is not there. You keep on refreshing the cache, and on the real time, whenever you do it, in the in memory, we'll have some kind of ternary data structure, ternary search data structure, or the try tree. And with that, it will try to hit the cache and get the data. So normally, how it is implemented in the different companies, whether it's a Flipkart or whether it's Amazon, right? Whether it's, for example, in the LinkedIn search, when you search for anybody's name, it doesn't mean that it will go to the database and get the data. They have some data already in the cache, and with which you'll get the result.
Okay. Thanks.
No problem. So I'll try to quickly. So basically, what I'll do, I'll try to talk about the first type of question that can come in the linked list. There are like 4 or 5 different flavors of the question that can happen in the linked list. I'll talk about the first today, and then I'll quickly take few questions from you, right? So the first one is detecting loop, and I'll consider it's like 5-star. The probability of this question coming in the video is very high. If you go for 5 interviews, and if they have to ask question from the linked list, I think this is the first thing that they will ask you in the interview in the linked list question. This is a very common question, but at the same time, it is very, very, very important, because the chances of it's coming again in the interview is very high. We'll talk about what is the loop in a linked list. So for example, so the loop means I have this 1, then this I have the 2, then I have 3, then I have 4, then I have 5, and then it goes to 2. So basically, it is a head node. This is the head, and after this, it goes like 2, 3, 4, 5, 6, and 2. So this has a loop. So this internal structure is a loop, right? So the first question that comes up is that check if loop exists. Can you guys think of anything? How will you find if a linked list has a loop or not?
Yeah, by taking 2 pointer. So one will move 2 steps forward and second pointer will move 1 step.
So basically, we take 2 pointer. 1 pointer is, so one, it jumps here, then it jumps here, then it jumps here, right? Another pointer which jumps 2 steps. It jumps here, then it jumps here, right? Like this. Make sense? and the smaller one will also keep on jumping like this. This will come jump like this. This will come jump like this. Like this, it will keep on jumping, right? So this is suppose one, second jump. This is third jump. This is fourth, and this is fifth jump. And this is the first jump, second jump, third jump, fourth jump, and then it again does a fifth jump, right? So I see that after the fifth jump, right, they have met at a point 6. So since both have met at a point 6, this is only possible when they all are running in circular loop, right? Because for example, suppose there are person one speed is twice the speed of yours, right? And if you both are running, if it is a single straight line, right? The two person will never meet, right? They will only meet if it is a circular loop when the fast person will again come back, right? If the two pointer, one is moving at the speed 2v, another is moving at the speed v, if they are moving or converging at one point, it means that there is a loop exists. So what we can do is that we can start from the head, run two pointers, one which moves at 2 steps at a time, another which moves 1 step at a time, and if they meet, then I say that the loop exists. Make sense?
Yeah.
Write the code for this as an assignment. Okay? Write the code for this. Make sense, guys? What you have to do, you have given a head and you have to figure it out whether the loop is there or not. The concept I have already told you, you have to just implement it in the language of your choice. Make sense?
Yes.
Perfect. Now, the second question in this type is that. So this 1, 2, 3, 4, 5, 6, and like that. So this is a loop. The second question that can be asked is that what is the start point of. Now tell me, how do we find it out? What is the starting point of the loop?
We can find where is the intersection happening, and
Okay.
like we'll be having the address. So from there we
Mhm.
can get the data.
So suppose I found that intersection is happening at this point, say 5. Suppose this is where they're meeting.
Okay.
So how do you find the start of the loop from here? I'm saying that the loop start. So the linked list. This is the head. This is the
Okay.
head. Okay, and from this point, this is the point where the loop is starting. 2, 3, 4,
Okay.
5, 6, 2. So this is the
Okay.
starting
Okay.
point of the loop. So you have to tell me find start point.
So start point is 2, right?
Yeah. So how do we find that 2 is the start point? This is my question.
Okay.
So I have another question. Can we have multiple loops in a linked list?
If it is a single linked list means every node will have only one node. So if that is the case, how can we have the multiple loops, right? A single linked list, one node have only one outgoing node, right? It is only pointing to the next node. So one node will only point to one single node. The only way the multiple loop will happen is that when a node can point to two different nodes, right? But if a node is only pointing to one node, in that case, I don't think we can have the multiple loops.
If you have to find the starting point of loop, 2 is the starting point, right? And 2 is pointed twice here. Like 6 will point also, and 1 will also point that.
But how will you store this previous node information? Because there's no way that you can go back in a linked list.
Yeah.
Are you getting my problem? In the
Yes.
linked list, once we have moved to the next node, we cannot go back. I cannot peek back into my previous node information. Astosh, you said that you have solved this question. Have you solved this one also? So right now, this is the point where both have met. So I have a faster pointer, I have a slower pointer. Okay, what do I do now?
We would reset the faster pointer to point at the head.
Faster pointer at the head, and I have removed it from here. Okay.
Move with the same speed.
I got your point, but how do you say with the confidence that both will meet at the starting point of the loop? How are you saying it? What is the logic? How are your hypothesis for this? I understand that they will meet, but how are you saying that the meeting point will be the starting of the loop? Meeting point. How can you say this? I'll try to prove this concept. Suppose, say, 5 is a point where the meet, like point of meeting. Okay, this is the point of meeting. And what I do is that suppose 1 till 3. Suppose this is the distance x, and suppose 3 to 5 is the distance y, and 5 to c is the distance z. Make sense?
Yes.
Okay. Now let's talk about a very simple mathematical concept of the speed, time, distance. You should be already knowing it. So if suppose in the same time t, if one is traveling at the speed v and two is traveling at the speed 2v, if this will cover a distance d, this will cover a distance 2v. Am I right?
Yes. Yes.
So suppose distance covered by first one d1. Okay. So d1, since 5 is the meeting point, so I can say the distance traveled by the the slower pointer is x plus y. Can I say this?
Yes. Yes.
Okay. And in the same time t2, what has happened is that the faster pointer would have covered this distance, then it would have covered this distance, it would have also covered this hole, and then again it has come up here where they would have met, right? So distance covered by the two, I can write x plus y plus z plus y, right? Can I say this? The distance traveled by the
Depends
faster
how
one.
many times it has gone through the loop, the faster pointer.
Okay. Since one speed is the twice of the second and the first one is moving linearly, right? Because in the first one is moving linearly, it means that the second time itself, because 2 and the 1 are multiple of each other. So so the first time itself when it was going back, it could have met. That is mathematically because 1 and 2 are multiple of each other. So the second time when it goes, it definitely meets to each other because when you divide 1 by 2, there is a multiple of each other. And that is the reason why you put the second pointer twice the speed of the first one. You could have also made it like 3 times 5, like first you move twice and second you move at the 3. In that time, you never know that when they will meet. But since one is a multiple of 2, so the next time when the second is taking the second loop, the first will be the pointing there. So it will go in the second time itself.
Okay.
Okay. So what I can do is I can write it like, make sense?
Yes.
Okay. Now d2 will be 2 times d of 1 because speed of d2 because speed of 2 is more than the speed of 1, so d2 will be 2 times d1. Can I say this?
Yes.
So I can say that d2 is x plus 2y plus z and d1 is x plus y, so it is 2x plus 2y, right? 2y will get subtracted, x I took to the right side, so z becomes equals to x. What it means that from the point where the intersection happens and to this distance, like if you find this distance, this is z and this distance, this is x, both are same. Start one pointer from here and you start one pointer from here, and wherever they intersect is the point of the starting of the loop. So that is why what we do is that wherever the logic that we need to use is that wherever they intersect, so point, this is the point of that intersection. So I start one pointer here, I start one pointer here, and I start both the pointer with the same speed. Since the distance of both this point from the start of the loop is same, so the point where they will intersect is the point of the starting of my loop. Make sense? Everybody? Right, perfect. So you need to write the code for this again as an assignment. The third kind of question that can happen in this loop is that what is the distance of the start of the loop from the head? So basically you have to tell what is x. So now this becomes very simple, right? This distance you can easily figure it out, right? So these are the only three combination of question that anybody can ask you in around the finding the loop in a linked list, okay? And if you know this question becomes very simple, right? So I want everybody of you to please try this, write the code for that in the language of your choice, but please do try it. It's a 5-star question. It is one of the the low hanging fruit, and the chances of this question coming in the interview is very high. So please do try this. Out of 5 interviews, one interview will definitely ask you this question. So this is about the loop. We'll stop here on the linked list as of now. We'll take one more session on the linked list, which is the next session, and we'll talk more about the different kind of scenarios. Okay. Any question on the linked list today, guys? Are you guys finding it easy?
Till now, yes, but not with the doubly linked list.
Doubly linked list is much easier than single linked list, dude. In the single linked list, the problem is you cannot move backwards, but in the doubly linked list, you have that advantage, no? So that is much simpler. Trust me, the doubly linked list is it's more easier than the single linked list. Single linked list, the problem is that you cannot come back. So that is why always, whenever you're doing anything, you have to take a lot of caution because once you have moved out, ek baar banduk se goli nikal gayi, you cannot come back, right? Similarly, in the linked list, if you have moved one step forward, you cannot come back. So it becomes complicated. But in case of doubly linked list, you can always come back, right? So it's a much simple data structure.
Okay.
Vivek, all good?
Yeah, so far it's good. Like while coding only, I don't know whether I will feel difficulty or not.
If you understand the concept well, right, coding is one of the simplest thing to do. The only thing is that you first have to understand things well. So you are able to understand what linked list is, right? I think
Yeah.
coding will automatically fall into the place, no problem. Paritosh, you were saying something.
Yeah, I was asking you, Vishwa, like in the interviews and all those stuff, like the singly linked list is only the most of the hot topic for the interviews, or doubly or circular will be also at the
No, no. I think singly is the mostly hot topic because the singly the question become complicated because of the nature that you cannot come back. In the doubly and the circular things becomes very simple. For example, if you have to reverse a doubly link, it's a very simple question.
yeah.
But the problem happened in the linked list because it is single, you cannot come back. So that is why you have to take so many care of. So mostly the questions will be around a single linked list. So that is why most of our effort will go in understanding the types of problems that we can solve in the single linked list, and very small effort will put on the double and the circular linked list.
Okay, thank you.
Perfect, then great. Have a nice day.